In today's lab, we're going to measure the muzzle velocity of this launcher, aka what this is a projectile launcher. It's going to shoot this little yellow ball. Oops. And we're going to figure out exactly how fast it leaves the end of this launcher. How we're going to do that is we are going to basically just use projectile motion. We're going to launch and see how far it travels in X, in the time it takes it to fall, and use that to figure out how fast it goes. We're also going to, for part B, figure out the maximum, what angle leads to the maximum range with air resistance. But let's start with part A for now. For part A, for the muzzle velocity, we are going to work with a launcher at 0 degrees. I'm a little zoomed out, so I don't know how you can see, but there's a protractor on the side of this. What I'm going to do is I'm going to figure out how far the ball drops. Again, I'm going to measure the height to the bottom of the ball and it goes. And they were nice and drew it right on here, so I can see it's right at 25 centimeters, which I'll write down. What then we're going to do is we're going to tape a piece of paper onto the desk, which I've already done. And we're going to cover it with a piece of carbon paper. What happens when you have carbon paper is if anything hits the paper, it'll leave a mark. Now I'm going to take the ball, I'm going to put it in here, load it, and then fire. What happens is where the ball hits, it leaves a little mark. And I will bring you over to see that. That dot right there, that is exactly where the ball hit. And so I can now see, where we collided. Now what I'll do with that information of where we collided is I'll use it to measure exactly how far the ball traveled in X. So I put this here and measure the distance. In this case, I'm getting the shot, 68.4 centimeters. I will write that down, which I will do in a second. And then I'm going to fire another series of times. A total of 5 times for this. I'm sure the audio sounds great on this because you're getting all sorts of things just cranking around. So I do apologize. And one last one, I think. I lost count. Yep. So what that left me is 5 dots in a rather impressive line, actually. And so I will measure the distance of all those 5 dots, and I will use that to figure out exactly how far away they are. Part B, we'll move on to part B in a split second. Moving on to part B, what we're going to do with part B is we're going to start varying the angle. Right now we're at 20 degrees. I can tell by the little protractor on the side, which once again is not very large in the video, but you can see the little hanging weight. But what I'm going to do is for a series of angles, I'm going to basically do the same thing. I will load, put a paper where it's going to hit, put the carbon paper on top, fire, chase down the ball, and figure exactly where it hit. I'm not going to bother moving the camera this time. You can trust me, and just a dot like before. Now, this is kind of interesting because I'm firing at some higher height and going to the ground. You might notice with the calculations, I make some assumptions that don't quite match that. So be careful about that. But what we're going to do is the same idea. We're going to measure how far that is. I'm going to do it 3 times for each height and then take an average. I'm not going to bother filming me doing it every single time. I think it's just going to be boring to watch the video. But that is what I did, and you can take that data and analyze it. Of note, to find the max range, you will be making a graph, but this is a very real graph. You do not need a Linus function. You do not need a best slope. What you're going to do is you're just going to look at the points and plot range versus angle, and just kind of by your eye figure out if you connected the dots with a parabola where the highest point would be. If you feel up to it, you could mathematically fit it to a parabola and find where the middle of that parabola is if you're aware of the math involved. But if you're not, as I said, you feel free to do it by eye. Good luck. I just ended that one saying that I was showing just 30 degrees, but just for fun, here's 70 degrees just to show you one with a real big arc. So I moved the paper in between videos, but here we go. I'm at, as I said, 70 degrees now. When I get out of the wheel height, I'll look like that. Well, once again, I'll measure the distance, which I'll do in a second.